How do we do this? Here, the question mentions the populations of two towns. Originally, they were the same. Okay, we don't know what this population was, so let's call it X. And let's make it here in a little table so that we can keep track of the figures and quantities in this question. Here, here is supposed to be 1985. So two different times are mentioned, right? And how these populations changed. So originally, the population of town A was X, and so was the population of town B. But in 1995, they had increased and decreased respectively. The population of town increased by 60%. So this implies that in terms of the initial population in year 1985, this could be expressed as X multiplied by the factor 100 plus 60 over 100, that represents an increase of 60%, or simply 1.60 or 1.6. While in the case of town B, since it suffered a decrease of 60%, the population 10 years later, that is in 1995, could be represented as the original population of town B multiplied by the factor that represents a decrease by 60%, which is 100 minus 60 over 100, or 0.40 or 0.4. So we have the expressions for the populations of town A and B in 1995. Now, let's translate the question carefully. This part. In 1995, the population of town B was what percent of the population of town A? So let's do this, in parts. The population of town B, okay, let's take it down here, was what? This expression, 0.4 times X. Was can be translated as the symbol of equality. What percent is our unknown? And so, since we're already using X to avoid confusion with the unknown of the question, let's call this percent here W percent, what we want to find out. So let's use the expression W over 100 to represent that percent. Of can be translated as simply the operation of multiplication. And then we have the population of town A, which in 1995 is represented by this expression. So 1.6 times X. So now, solving for W will yield exactly the answer to the question, but we don't know X. But you see that X is a common factor on both sides of this equality, so it can be cancelled. Finally, W is calculated by multiplying 0.4 times 100 and divided by 1.6. You can see that if we both multiply by 10, numerator and denominator is the same as saying 4 times 100 over 16, right? Let's get rid of the decimals for a moment to simplify faster. Divided by 4, divided by 4, and then 100 divided by 4 yields 25. So this number is precisely the answer to the question. Okay? So whenever you have, for example, quantities for which you only know the percent changes between two periods of time, so you can assume some initial values or variable for the original values of these quantities. Particularly in this question, since the two populations were originally the same, we could assume the same value X for the population in year 1985. Then representing the further values of the quantities in terms of those original variables helps, connect the quantities according to the relationships the statement establishes. and then translating the final question in the problem using the translation key we talked about earlier will help build probably an equation or formula that you can solve easily using basic rules of algebra, right? So that's why we can get, using this approach, to the answer of the question, okay? And it's kind of a bit more structured and clear if you use this approach. Of course, you can also try a different way. Some people, for example, decide to assume some value. Say, okay, if the populations were the same, let's say that in both towns, the population was originally 1,000 people. And then they work with numbers, modifying the numbers with the percent increases or decreases what that the question describes. Yeah, it's also possible. Okay, you will have to use your calculator probably if you have more numbers. If you just use letters or variables, well, you avoid using the calculation unnecessarily. Here, you see how we can do this without using the calculator at all. Okay, and that's sometimes more advantageous in terms of time.